Morning, folks. It's great to talk to you on Thursday, October 3rd, 2019. As you can tell, I'm not here today. I'm out setting up for our city cross-country meet, but I wanted to get you guys excited. Start out with a little wahoo, whoop, whoop, and get down. Today, we're going to be discussing quadratic functions and zeros. Why don't you go ahead and get started on the warm-up, and when you're done with that warm-up, then you can restart the video. So go ahead and pause and give that warm-up a shot. All right, now let's go over those warm-up problems super quick. In order to convert from, what would this be, factored form into standard form, the first thing you need to do is distribute. So distribute these two together, so you still have that -1 just kind of sitting out there. You're going to get, what, 2x squared, sorry for being a little sloppy right there, plus 3x minus 10x minus 15. And when I distribute that negative, I'll end up with the function f of x equal, I'll have a -2x squared, 3x minus 10x is -7, but now the -1 is going to make that positive 7x, and then the -15 becomes positive 15, and that's all we're looking for. Now, to convert vertex form into standard takes a little bit more work. Distribute that x minus 3 times x minus 3. That has to be our first step. We're going to then distribute to 2, and then add the 5 in at the end. So we'll end up with 2 times, you multiply x minus 3 times x minus 3, you get x squared. Minus 6x plus 9. Hopefully you already had that. Distribute to 2, and we end up with 2x squared minus 12x. Now 2 times 9 is going to be 18, but I'm going to go ahead and add the 5 and get 23. So I can go straight to my solution right there, again, to save a little bit of time. So those would be our two from factored form and from vertex form, how to convert then into standard form. Now the last warm-up problem, this is the one that's probably the most critical that you're able to do. Go from the vertex, given the vertex, and another point. Okay, we've got this other point right there. Please find the vertex form of this function. We've got to get vertex form because we're given the vertex. We start out with f of x equals, we don't know a, we don't know the a value, but we do know we're going to have x, and this is going to be plus 4 quantity squared minus 3. And the reason we know that's true is because they gave us that vertex. Now we use the -2 and the 4. Remember, -2 is my x value and the -4 is the outcome. And I'm going to replace x with -2, and I'm going to replace f of x with -4. So I'll rewrite that. I know that I'm going to get -4 equals a times, again, what was the x? -2 plus 4, try to keep the colors here so it makes sense to you all, minus 3. So does everybody see where that came from? We got the blue from what we're given as far as the vertex goes, and the -2, -4 substituted in for x and for f of x. Now we just go ahead and solve, and we end up with -4 equals a times -2 plus 4 is -2, squared is positive 4. Minus 3. We add the 3 to both sides. We get -1 equals 4a, and when we divide by 4, we'll get -1/4 for a. A has a value of -1/4. So we go to write our function over here. Not too terribly bad. F of x equals that a value, -1/4, times x plus 4, quantity squared, minus 3. So that's going to be our function. All right. Hopefully that's a good warm-up for you. Now let's get rocking and rolling into today's lesson. Again, if I go too quick, you can always pause, rewind, or fast forward. Recall, it says that x-intercepts, all right? These x-intercepts, we use that word a lot. X-intercepts of a quadratic are also known as zeros. Okay, we call those zeros. Also known as roots. They have a lot of names. They're all the same thing. They just go by different names based off what we're referring to. They are the x values that when substituted into a quadratic result and the value of f of x equaling 0. So what we mean by that is any x value that I can plug into that function that gives me a 0 as an outcome is considered a root or a 0 of the function. Remember when we graph these things, when we graph a parabola, that the values are going to be where they intersect the x-axis. All right, hence the reason we sometimes refer to them as zeros of the function. Now, how many times could a parabola intersect the x-axis? Now, I just drew this parabola up here. I'll move it around a little bit. It could intercept the x-axis twice, like I had it drawn originally. It could intercept it just once if the vertex happens to be right on the x-axis. To use your geometry term, we call that a tangent to the x-axis. And then we could have a parabola that's up here somewhere that never once intersects the x-axis. So the possibilities, the number of intersections could be 2, could be 1, or potentially none. We could have not one x-intercept on our graph. So what you're going to do is you're going to take the TI Inspire, you're going to punch in a few of these functions and get an idea as to what they look like. When you're done testing out 1, 2, 3, 4, 5, and 6, you can hit play on this video, and then you can check your answers real quick. So go ahead and hit pause, put those into the TI Inspire, and give them a shot. All right, you're back. And if you put these into your TI Inspire carefully, you should get a parabola that looks something like this for this particular problem for number 1. Obviously, that's going to have 2 real zeros. Taking a look at that function, it does open down, makes sense. All right, number 2, when you carefully graph that in your TI Inspire, you should have a parabola that roughly looks like that. That does not intercept the x-axis at all, so it has 0 zeros. And finally, number 3, if you graph it carefully, should come down and be tangent. Should have only 1. The vertex is legitimately filling 2. That vertex is also your 0. It's kind of double duty right there. All right, yes, I did say duty. All right, moving on. Checking numbers 4, 5, and 6. Number 4, if you put that into your graphing calculator carefully, should be the exact opposite of the one we just talked about. Should have a point of tangency. Oops, sorry about that. Got a little bit above, and it should be right on there with a point of tangency. So it has 1 real 0. All right, number 5, if you graph that one carefully, drops down in vertex in that 4th quadrant down there. All right, has 2 real zeros. And finally, the last one, vertex is going to be again in that 4th quadrant, but this one never does touch the x-axis. So it has 0. So did it work out that every one of our options was either 0, 1, or 2? You can say yes to that. And I'm done with this video. You can check into the other videos for the remainder of the lesson. Thank you very much.